Okay, so we're just going to finish off 3-6 today. And we're just going to do the last kind of problem that's in there, and then we'll have time for questions too. Or work time, whichever you want. Okay. Casey, what's the velocity here? It's the what? Okay. You could put ds dt, it doesn't really matter. So you guys should have written down the derivative of that by now. Good, what is it? Minus 12t plus 9. Now, they don't ask this yet, but how do you know if the particle has stopped moving? No, and I'm as guilty of this as well. We have to not use the word it. How do you know the particle has stopped moving? Velocity is 0. So we could find that. And on the exam, unless it's a calculator problem, it should be something that's factorable. This one's factorable. In the homework, because somebody brought it in this morning, it wasn't factorable. You have to either use quadratic formula or your graphing calculator to solve. So I didn't like that. Although it is hard to write these problems so that you can factor them, so that everything works out nicely. If one thing works, something else doesn't. Well, before I factor this as a trinomial, I'm going to factor out the 3, because that goes into every term here. T squared minus what? 4t plus 3. And before I graph this on my graphing calculator, it helps to analyze it a little bit too. Okay. And honestly, they're not any harder than factoring that on the exam. And yet there are a number of students, because I graded that problem, that couldn't factor that. It wasn't this problem, but it was one that had to factor something like this. T minus 1, t minus 3. So it stops at t equals 1 and t equals 3. And they'll ask you that directly. When does it stop? When is it moving to the right? When is it moving to the left? And how do you know? That's the other problem. How do you know? Because the velocity is 0. So where's your justification? It's right here. So let's say you're not very good with the algebra, but you understand the math and the calculus. You say this, you get a point for that. You would get a point for that. Then a point for that. Okay. You guys find the acceleration? Try not to go too fast. This way? Oh, you have it. How I factored it? Okay. Those of you who are caught up, find the acceleration. How do you find the acceleration? It's v prime of t, which is, I look up here, 6t minus 12. The acceleration with the velocity together helps you to figure out if it's speeding up or slowing down.
Oh, yeah, yeah.
Ben, is that okay? Can you see?
Yep, I got it. Oh, yeah.
Okay. What's squared? I take the derivative of 3t squared, which is 6t minus 12. Okay, that's good. Phones, please put phones away. Okay. It shouldn't even be out on your desk. Now, here's the question. How do we know if the particle's moving to the left or moving to the right? If it's going to the left, do you remember this from yesterday? The velocity is what? Negative. How about to the right, James? Now, what I'm going to do is draw a little line graph to help me, but it doesn't count for anything on the exam. You don't have to draw it. I like to see you draw it because it really does help. So here's my velocity, and we're going to do a lot with that this year. And so that's my velocity. I think that's crooked. Oh, yeah. I've been pretty good about not being crooked. Okay, and I need to know where the velocity is positive and where it's negative. Now, just because the velocity is positive and it goes to 0, does it mean it changes direction? What has to happen for the particle to change direction? No ifs. Velocity has to change sign. Now, it's not formally written up in this section, but you might as well hear about it. Okay, so we have 1 and we have 3. We know it stopped there. And I know that my position, or my velocity equation was 3t squared, like I don't have this memorized, minus 12t plus 9, right? Now, you can be clever, and you can figure out the signs. That sounds like some people have already done that. Or, we factored this, and we said v of t was equal to 3 times t minus 1, t minus 3. Oops. And you could just test regions. Because if any number to the right of 3 makes this positive, they all do. There's no other place. So basically, you're solving this quadratic inequality, less than 0, greater than 0. But I'm not going to write that out because that's kind of tedious. So I put in 100 here. What's going to happen to these numbers? Is it going to be positive or negative? Positive. Now, how about if I put in 2, because that's a nice number between 1 and 3. That's positive 1. 2 minus 3 is negative 1, right? So that's negative. And 0 is an easy one, but I'd rather put the 0 into that form because that's easier to work with than that one, actually. And so is it positive or it's positive? Surprisingly enough, we make a lot of mistakes figuring out the signs. Now, I like to be clever. I'm pretty lazy. So there's another way to do this. I'm trying to get my other pens. Oh, there it is. I know that this function is a parabola. So if I graph it, it has to look like this. Well, right now, this is above the axis, so it's positive. This part here is below the axis, so it's negative. And this part here is above the axis, so it's positive. I don't have to test those regions. I can look at the picture. But that's up to you and how you do it. So when is it going to the left? Between 1 and 3. I don't get to include 1 and 3. It stopped there. Then, when is it going to the right? From negative infinity to 1, and then from 3 to infinity. Well, it's solving a quadratic inequality without me actually formally saying that. Now, you don't necessarily, you will get no points for this nice little graph, but it helps you. It's a tool. It helps you to figure out what the signs are. Okay, so now we know that when t is 1 and when t is 3, this particle is going to stop. And we know that before you get to 1, it's going to the right. Then it's going to come back. And then it's going to go to the right again. Now, what you don't like about this is that we actually are going to have one-dimensional motion. You want to see two-dimensional motion. That's not what it is. It's kind of like hockey, except that the puck is supposed to stay on the ice. But if you just slide it back and forth, you're not seeing any vertical motion most of the time. So I need to make a table for the time versus s of t. So s of t, so I can keep this in my head, is, now this is not hard. This is substitute and evaluate, but I'm going to give you a better way to do it, an easier way to do it, and I don't care if you use a calculator. So I'm going to try to graph its position as a function of time, this particle. So what's the easiest time value to put in there? And so what's my position? 0. Well, 1 isn't so bad either. S of 1 is equal to 1 cubed minus 6 times 1 squared plus 9 times 1. We can do that. 1 minus 6 plus 9 is 4. Be careful with the, I'm glad for that mistake, because some of you look at this line right here and think it's that line, and they're not the same. I call it the case of the invisible parentheses. And we're actually pretty kind about that on the exam, because you'll end up doing the right work, but you'll mess up your parentheses. So anyway, that's not what that is. So it's going to be 4. And then I could do 2. Now, 2 isn't hard either. It's 2 cubed minus 6 times 2 squared. At least I don't think these are hard. But it's what? It's tedious, isn't it? You don't mind substitute and evaluate? Oh, I do. It takes time. So you know what I'm going to do? I'm going to kind of cheat. I'm going to use my calculator. So if you haven't done that with your calculator, well, they won't give you anything that's as complicated as this. Would be easy. So I'm going to change my calculator back. Yeah, I will. I think it is too. But I'm going to, okay, so everything should be over, it should be cleared. And I'm going to put y equals, and I'll give you a chance if you want to do it with me. I typed in the function. Now, I know these are t's, but it doesn't matter. But that's s of t. I'm not graphing it. But I'm going to use my table of values because all this table is a time and position. That's it. That's all it is. So, are we ready? Okay, I do a second table set. By the way, if you always want to know what your outputs are going to be, I go look at the table because that's fast. And I'm going to start at 0. I'm going to count by ones, and then I'm going to go second table, and there it is. Why should I go through all the work of substitute and evaluate when I know what it is? It seems kind of silly to me because that's not the math. Well, let's call it S&T. Now, the part that's going to bother you is right now, we're going to graph that. And the problem is, I'm not doing it vertically. It's like foosball. The puck is going to stay on the surface. It's just horizontal. It's not going up in the air. So, but the problem is, you know, if you're playing hockey or whatever, the puck goes this place, and somebody hits it back, and then somebody hits it back. I see nothing there, right? I see this horizontal line. So I have to cheat a little bit in terms of how I write this out. So first I'm going to graph when this is time, right? My position, I'm starting at 0. Do we necessarily have to start at 0? No, my position might not start at 0. On the exam, it's rarely going to start at 0. And then you could label it. So this graph is strictly a position graph. There's no time. So what you do is you say t equals 0, s equals 0. Okay, and we said until you get to 1 second, it's going to the right. So when t is equal to 1, or 1 minute, whatever it is, I'm going to be at 4. So there's my point. So that's t, this is just the position graph. T equals 1, my position is going to be 4. And if at t equals 1, we said it did what? It stops, doesn't it? Does it turn around? Between 1 and 3, it was negative, right? Means it's going to go to the left. So it's going to stop, and you can see it's got to go to the left because after 2 seconds, it's got to be back to 2. No guarantee it turns around there, but we know it did. So it's going to be here. And let's see, then what's it do? At t equals 3, it's still going left. It's going to go here. And what's it going to do there? It's going to stop, right? I could label it. I'm trying to figure out how I can do that. T is equal to 2. After 2 seconds, my position's at 2. After 3 seconds, we know it stopped. We figured that out. T equals 3. My position is going to be back at 0. Could be anywhere. I don't know, but it happens to be here. Okay. Then what happens? At t equals 4, we've moved back to position 4. Well, you're going to see what the motion's doing. And then after that, at 5, it's going to go up to 20. So is it speeding up? Yes. Well, I can get that motion on my calculator if you want to see what it looks like. Okay, Casey. No, you probably should at least put the S down so it's clear. You know, actually, should go up here like that. Now, it really is doing this. It's going to the right. It's coming back. It's stopping, and it's going to the right again. But when I'm done, I don't see anything. the problem. So let's look at that on our graphing calculator, and then I'll show you how you can actually see it a little bit better. Now we have to change modes. This year we don't do parametrics, but I have to go to parametrics to see this. Here's where the Inspire actually doesn't do very well. Because I don't get motion for some reason. I don't know why. So we're going to go to mode. Now, if you're going to do it with me, I'll make sure I go through slow enough. Well, you have to help me with that. Yes, you may use 2 calculators in the exam, but you may not bring in colored pencils or highlighters. No. Sorry about that. I don't know. I think it's silly, but maybe it's for our eyes. I don't know. I think it's ridiculous. You should be able to do it. Or maybe it's just to keep things equal. Some people maybe can't afford to go out and buy the highlighters and the pencils. I don't know. They can't. What happens is they get the calculators the day before the exam, and that's why they fail. Okay, ready? That's one of the biggest things, because I work at the College Board, and I go all over the country. The biggest thing I run into with the other teachers is we don't have calculators. I said, they have to have calculators. Well, they don't have money for them. And a lot of the schools that I go visit, the kids don't have the money for them either. Okay, so we're going to go down here to parametric. You've not probably done this before. So we go over to parametric, press enter. And now when you press y equals, you're going to see some strange looking things there. Ready? Okay, this is horizontal motion, right? Put it in for X. You could do it the other way around. It really doesn't matter. But I'm talking about it moving horizontally on the table. It's going over here, and it's coming back, and then it's going. So I'd rather do that in the horizontal, but it makes me put something for the Y. Now, I don't want to see this horizontal motion on the X-axis, because then I'll never see it. Yeah, oh, yeah, I have to go to the window. Trust me, I haven't done that yet. But let's put this up at 2 or 1. It doesn't matter. Just make sure it's not on the axis. It's a constant. So I'm going to graph my line maybe on a table that's on top of my table. It's up here, so I can see it. Otherwise, I could leave it at y equals 0, but then I better turn my axes off where I can't see it. Something else you want to do is make sure that you go up here, because you really won't see anything unless you put this little circle trace on. Because remember what it's going to look like. It's going to look like a horizontal line. I said put your little circle trace on. Do you remember how to do that? You go over here and press enter on the calculator until you get that. Now I like the little trace piece to it, where we have to change first to parametric. And we don't have to know this year. Next year you will. That's okay. Good to see it. Okay, we're ready to look at the window. That looks really weird too. Now, remember our little chart at 5? Where were we at 5? We're at 20, right? This is what I do. I will. I look at this little table to figure out what to set my Y values at if I don't know. Rather than playing around or doing zoom fit, I just go right there, look at it, and set it, because that's faster. So the Y values are going to go up to 20. So let's go 0 to 5 on the time. I found T-step at 0.05 is pretty good. I play around with this. If you go 0.01, that means every 0.01 units, it's going to make a mark. So it's going to go slow. This does show you time and speed. We're going to put X min at -22. Press window. If you're in the right mode, are you in parametric? Because it stops. Remember, the particle stops, turns around. Oh, because my T only went to 5. Oh, I'm going to go down there. Okay, let me take a picture of this. Then you have it. Like the other way this used to work, but anyway. And then X scale, you can cut by ones or whatever. It doesn't matter. The Y minimum, I set at 0. We could make it -1 if you want. Y max, I put up at 6. You'll see why I went to 6 in a moment. Doesn't matter. It's going to be bigger than 2 for the moment. Okay. Now, are you ready? You got to watch it because it's going to move. Oh, we don't have the functions in. Okay, now you should see acceleration. There it goes to the right. It's going to stop. It comes back. It stops. And then it goes to the right. And does it speed up? Yeah. Okay, so if you put this paper, huh? Probably not. But if you put that on your paper, that's a little problem. It means nothing. So what we do is we do kind of what I did over here. I kind of come up. Well, we can't do it. I don't know how to do it like in steps like that. You can't. So what we'll do is we'll do a little trick here. Go into y equals, and let's make this just plain t. Now think about what's happening. When t is 0, the y value will be 0. When t is 1, the y value is going to go up 1. So it's going to be sort of stretching it out like vertically. Ready? To do it again, you have to rekey it. Okay, ready? Okay, there it goes. It's going to go to the right. It's going to stop. It should slow down. It goes fast. It stops. And now it speeds up, and it's going to go to the right. I don't know why they inspire. What it will do for me is just give you this picture. So it will not do it in motion like I do here. Question. I had to change the y. So if it's sort of like what I was doing before. You know, it goes to the right, and then it goes to the left, and then it goes to the right. I'm going to change it again, but I made it T. Now, if I want it a little more squished, I'll make it half T. You can do whatever you want. I'm going to make that 0.5 T. Now I'll graph it. It'll be squished more. Going pretty slow there, isn't it? Then it starts going faster. It depends on your resolution, what that's set at. And I don't know what yours is set at or mine's set at. I don't even know how to, I mean, I know how to change it. I don't know what it does. I never played with it enough. Okay? I can't do it horizontally, totally horizontally, or you can't see what's happening. I think it's kind of cool to see the motion. And that's what parametrics give me. They give me time. Otherwise, it's a static graph. Right word. Okay. Now, we are going to do, I'll let you think about that. We are going to do an AP problem. Now, on the exam, they changed it up. There is a regular form, and there's a Form B. Okay? The regular form is what we've always taken. Form B is what they take in Europe. Well, this year, they changed it. We all took the same one, except for some schools, some places, took a secret form. So there is no Form B, unfortunately, because I like it for the extra practice, but there isn't. And we took the regular form because it was what was released, and you guys came back and told me it was on your test, because I don't actually get your test back. Before, you used to get a form, and it was in a separate booklet like this, and then you just worked over on a little booklet. Now, this problem is printed in your booklet. So unless you tell me what the problem is, I don't know. Anyway, we had the regular one, huh? No, you probably want to be in function mode. It's going to mess you up. So there are secret ones. We didn't get the secret ones because everybody told me what was on the test. And then I saw the test. I go, yep, we didn't get the secret ones. I have to sign off. Yes, you can use physics to help you with this. I had to sign, if I didn't grade that one, but if I did, I had to sign off saying I will not release any of the information on the secret one. I don't know if there's going to be a Form B this year. I was shocked there was not one last year. Okay, this is your first practice. Now, the other thing is, they name the problems by what the problem's about. We've had the oil spill problem. This is what I'm sure they called this the squirrel problem. Now, before I start to do anything, notice it says, okay, you guys, they've changed this, but you had 3 problems without a graphing calculator. This is without a graphing calculator, but you can see the geometry there, right? It's trapezoids. The minute I see geometry and shapes like that, I know I'm going to have to find area. But and some of you in physics know how to do questions B and C already, which is very cool that you know that. But if you don't worry about it. We only really, in this class, can do A and D, part of D. Okay, first thing you do is when you see a graph with a picture, I call it a visual. You look at it and you say, what is that a picture of? Is it the function or the derivative? It's what? It's V. If the function's position, this would be the derivative. So I would, and you can't use colored pencils, but when I'm doing this, I would read the problem twice, because that's not a position graph. This is a velocity graph. And you think it's not a big deal, but it's a huge deal if you don't realize it, because it says right there. And something else you have no practice with, reading every single word. Squirrel starts at building A at t equals 0, travels along a straight wire connected to building B. Have you ever watched the squirrels out there? I watch them once in a while. They jump a long ways. I watched one squirrel go from like over there all the way over there, never getting on the ground. And he had to do a big jump to get from one tree to the other. Amazing. Yes. Okay, so we're going to model this squirrel's velocity, not the squirrel's path. Right there. Okay. Read the question and answer the question. That's the other big complaint I have is students don't answer the question. It says, at what times between 0 and 18, that's important, does the squirrel change direction? I like to answer the reason before I do anything. How do you know the squirrel changes direction? Is the velocity being 0, is that good enough? No. I don't know about you, but when I drove to school today, I had to stop at a couple lights. And my velocity was always positive, assuming coming to school is positive. But I didn't change directions. The velocity has to change what? V has to change signs. I know you're not used to this, but if I write the reason, first off, that's a point. That's a point right there for saying that. And we should get 4 on this one. So where does the velocity change signs? Check. Yeah, ask. I don't know what we're in, but we don't care. How do you know the velocity changes sign? This is the velocity graph. Velocity is positive, and then it's... So where is that? 9. Changes sign. Don't say it's 0. I mean, you can, but you better say it changes sign. It doesn't have to be 0. It could be undefined. But anyway, where's the other one? Okay, you just got 2 points. And that was easy. Yeah, don't make the problems hard. I know they look hard, but don't make them hard. You have to read the things. Now, B, I really can't do B because I have to do what they call integral calculus. I have to find areas under curves, although you could find the areas of those trapezoids. Because this is the full problem.
The area of the trapezoid is 140. Let's just go with that.
Pardon? Well, you can kind of intuitively look at this. The velocity is positive, and you have to know a little physics that the distance you travel is the rate times the time, so it's this area under this curve. But we'll do that later. And then what happens? He's going to the right, and he comes back. But does he come back as far as he went right? No. You can see that. So the question is, when is he furthest from the building? You probably could figure that out. Right. And we don't have the calculus to do that. We will. Now, we can, some of you know distance. We're going to do D, but But I have physics people in here who want to do C, so bear with us for a second. The distance, not the displacement. So if he goes it goes across the wire, he comes back a little bit, and then he goes back again. You have to add all those distances up. The displacement is, you don't add them up. But so you have to find this area, and this area, and add them up. The answer is 215. If you haven't had the physics, don't worry about it. We'll do it. Yeah. It's the difference in where you started and where you came back. Yeah. Okay, so we really can't do C either, but we can do, no, not yet. But we can do D, the acceleration, and the velocity. Oh, the acceleration is way easier than you think. Now, I want the acceleration, but be careful, not on the whole graph. Just between 7 and 10. So how do you find the acceleration? It's the derivative of the velocity. And guess what? Between 7 and 10, the velocity is constant. Not constant, but it's a straight line. Can I write the equation of that line? Or actually, I want acceleration. So what's true with acceleration? It's just the slope of this line. To write what? You could call it v prime of t, or it's the second derivative. Okay, these are other ways to write acceleration because that question came up. So all you have to do is find the slope. You must show your work. So it's going to be 20 minus a negative 10. I know it's easy. Okay, I just want this acceleration as the slope of this tangent line, right? So I just take this ordered pair. I can't read this down here. What does that say? Okay, so then it's 7 minus 10. So that's 30 over what? Negative 3. So the answer is negative 10. This is just fine. It's just fine. You do not have to simplify. If you simplify it wrong, you're in trouble. I'm just finding the slope between 720 and 10, negative 10. Because what is the acceleration? It's just the slope of the tangent line. Can I find the equation for the line? Yeah. I know you guys like to do slope-intercept. I don't. There's my ordered pair. I don't care which one you use. And I now know the slope, so it's done. So for the velocity, it's v minus, which ordered pair do you want? Okay, v minus 20 equals negative 10. Or you could write that whole difference quotient, that's what that is, in there. It doesn't matter. And then it's t minus 7. Now, just to get you ready, because I know who the chief reader was for this year, he liked you, and this is fine. You get all your points now. No, and I never will be. Because they have to be a professor at college. Oh, no, I don't know as much as those guys. It says find the velocity. No, these guys have been doing this all their lives. Okay, I've only been reading 3 years. I think it's 3 years. Okay, it says write expressions for the acceleration. Acceleration is constant, so that was easy. And the velocity, which is not constant, it's this line. Well, in BC Calc, we really want this 20 on the other side. And when you take BC Calc, you'll see why. And that's kind of nice. You could simplify it, but I don't care. But you get full points with this one, so it doesn't matter. When we get briefed on these problems, we get everything that you could possibly do. I have 2 pages, 2 full pages like this, written out in lots of tiny writing, because it won't fit. Okay, so let's check our answers. And when you go online, the answers are there. You get a point for the 2 values and 1 point for the velocity changing sign. That wasn't bad. You get 1 point for your acceleration and 1 point for your equation. Any form, it doesn't matter. So that is 4 points there. If you know the physics, and you can find the total distance, because we haven't had the calculus yet, you've got 6 points probably. And that's enough. Now, you don't want to skip things. You want to do everything you can. With some problems, you might get 9. Other problems, you might get 3. No, they're all numbers. They're all numbers. It's a possibility, but I don't even know our school code. Everybody says that every year. And I get cute little pictures and things like that. Have I ever had what? Something? I would know the writing, but no, I've never seen it. Oh, we get some really good stories. So a lot of times we get apologies. Sorry, I don't know the material. But you know what? It's not their fault. They weren't taught the material. So that's the problem. More so in BC than the ABs. ABs, because BCs, they just usually aren't taught the BC topics. Okay, so now it's time for you to ask me questions, or you can have work time, but I think they're questions. Now, let me also tell you, Monday morning, I have a meeting at 7, but I should be out of that meeting by 7:30. But you can go see Mr. Dahman anyway in his room. So if I'm not there, he's there. Mrs. Hersman's around too. Monday afternoon, I have math team, and I forgot I have a doctor's appointment. I don't even remember making the appointment. But anyway, I can't change it, or it'll be another 2 months before I get back in. So I got to do that. But I'll come back Tuesday. It says we're out at 3, but I'm pretty sure we're out before 3. Well, this is one of them. I can give you the AP packet, but right now you have a quiz to worry about, and it's not as hard as that packet. We have a quiz on Monday.
We have a review for right now.
Well, it's on this stuff and velocity and acceleration, which we just did. And you need to know your derivatives or your trig. If I could get my signs up, and I haven't done it, you'd have a little bonus there. But now, the other class, we did questions out of the homework. Yes. So that's 3-5, because that's what's going to be on your quiz. Now, we did, oh, there it is. We did 37, but I think we should do it again, right? Gone. And we did 38 and we did 39. 38 is very similar to 37. 39 was tricky. Okay, you ready? Now, if you haven't done these, you need to at least do the odds and practice a little bit. Because what rule do I have to have here? I got a couple issues here. I have to do the quotient rule. And the last class said, would you please write it up here again? And I said, sure. Don't ever hesitate to ask, because I don't always think of everything. So it's low, the denominator. Don't memorize it as f and g, because it might not be those. It might be other functions. Times the derivative of the numerator, that's low d high, minus high d low. The square of low we go. And we never multiply that out. We just leave it square. And here's the thing you're going to like about this is we're not going to simplify this. So we're going to start with the denominator. And then we have to do times the derivative of the numerator. Now, I never remember cotangent, but I do remember all the cofunctions are negative. But I do know that the derivative of the tangent function, does anybody know that one? Secant squared. Is that okay? So what do you think the derivative of the cotangent is? It's negative, not secant, but cosecant. Okay, girls, you see the patterns I'm looking at? You should do it with me. Minus.
I can do it.
The denominator, you can do the next one. cosecant of x. Oh, no, no, no. I already did that. It's the cotangent. And times the derivative of the cosecant. Well, what's the derivative of 1? 0. Oh, we know the derivative of the cosecant. Because here's what I do. I remember the derivative of the secant. And that's secant, back again, tangent. So this is, and this is going to be what? Plus. Now, it's a cofunction, so it's negative. Okay, you guys? Guys, not right now. What's the derivative of cosecant? If secant is secant tangent, this will be cosecant cotangent. These match, so the cosecant has to match. That's a tangent, that's got to be a cotangent. I'm just using logic to say can't be the same because it's not the same. Over 1 plus the cosecant of x squared. Do I have to simplify that?
Yeah.
No.
Oh.
Declan, you got that? Don't have to simplify it. But where are you going to be able to check your answers? You go to Schoology, you go online and look at the solutions. The last guy said, oh, we'll go to Wolfram Alpha. I said, that's fine, except that they're going to give you a simplified answer. And you have to type it in. I don't want to type it in. It's very annoying to type it in. It's a lot easier just to go look at Mrs. Hersman's work. I don't care about that. What about 39? If you haven't done it, you should do it. Why are your paper throw away? We still have 8 minutes left. Oh, you can't do this in your head.
You have to.
Okay, they're going to come up and do this problem. No?
Yeah, I heard her say it too. She can do it in her head.
Now, I still have not figured out why you don't see the product there. So I put the dot there. Anytime it's 2 functions and they're multiplied and you can't multiply it out, you're going to have to use the product rule. So you're going to come up and try?
Yeah. Do it. Yeah, she said she could. I'll set it up.
Come on. I only got 5 minutes. It's the quotient rule, right? So it's what? Secant of z times the cosecant of z times the derivative of the numerator. I'm going to write it anyway just to keep track. Minus the numerator. Now, let's get the plan. Now, it's the derivative with respect to what variable? Z. Oh, if you got that, that's huge. You can't, because I'll tell you, this is really hard for me, the C's and the Z's for some reason. I don't know. Cosecant of Z. This is my plan. I haven't done it yet. I have to find the derivative. Notice this is the plan. I will take more board space to do that. And it's over what? The denominator squared. And I believe, if I remember in the quiz correctly, I mean, this is harder than what's in the quiz. This is not an easy one, I don't think, because you have to do both the quotient rule and the product rule. So, no, I'm just going to leave all that stuff. Because you know what? You could take forever and fool with trig identities to get it to look like a certain thing. Who cares? No, we have stuff to do that derivative. You could do it someplace. I'm going to do it later. But it needs to be done. Okay, how do we do that? So, yes. I don't know what that is. Secant, that's 1 over cosine. That's 1 over sine. No. Okay, so it's this the denominator times the, sorry. Don't confuse me. This is the first one times the derivative of the second. What's the derivative of cosecant? Okay, Jack? I should get a whole bunch of you for that. What's the derivative of the cosecant? Negative, because cosecant. Well, secant is secant tangent. So cosecant is cosecant cotangent. plus, oh, sorry, disease, plus, then I leave the cosecant alone, times the derivative of secant, which is secant tangent. Because I've memorized it. Yes. Now, what's going to happen? Well, you could always figure it out, but it's a time test. And when we reverse it, you're going to need to know these. So yes, it's time to memorize. So this I'm going to put right up in here for this. So all of that will be replaced by that mess, and it's fine by me if you just want to draw an arrow like I did, because who wants to waste time writing something as long as you understand what you're doing? And I don't care about that. Yeah, as long as it's clear. Some of you guys, it's not always clear, but as long as it's clear. How about other ones? Can you write the equation of the tangent line? Should be able to do a problem like 60. We did, you want to, I mean, we can do 38. 38 is just like 37, though. That mess? You may leave, you do not, you can even leave it with the 0 on it. We don't care. I mean, it's nice to simplify that 0 out, but don't waste your time doing that. Because if you are trying to simplify that, you're going to spend more time simplifying than doing the problems that you need to learn how to do. How about did I do 63? Let's do 60. Oh, let's do 66A. I assume it's been assigned. No, we got 5 minutes. Oh, I don't like that thick one. Well, that clock could be off. I was going by my clock. No, no, no. This is typical AP. Okay, guys, I know it's Friday and everything, but it's not close to time. It's at 11 o'clock. We still have 5 minutes, but I always give you 2 minutes off. Okay, how about this one? How do you find horizontal tangents? They might ask you, find the equations of the horizontal tangents. That means you have to find out where it is and what the y value is. But this question is simply where are the horizontal tangents. So, Sophie, how am I going to find horizontal tangents?
I don't know.
Yeah, you do. If the tangent is horizontal, what's true about the slope? There's my little aid. 0. So I want g prime of x, which is the slope, right? Do we have that down yet? I want that equal to 0. Now, this is trig. They expect you to be able to solve that. So what is g prime of x? 1 minus derivative of sine is no positive. The derivative of the cofunctions are negative. What? Okay, guys? So where is this equal to 0? Don't run them together because it's really not correct. Okay, so the cosine of x equals what? Okay, how are we going to find that? Yes. Far enough? Do you remember what cosine looks like?
Oh, yeah.
Where does it start? Okay, where is the cosine equal to 1? 0 where else? 2 pi. 4 pi. I didn't look to see if this was restricted, and you could go backwards. I can say multiples of pi, but I want even ones, right? So it's not n times pi, but I need even numbers, so it's 2n times pi. But, okay, so that's what you do. Okay, time to go. Have a good game tonight. Stay warm. Stay safe, you guys. Bye. Have a great weekend, you guys.